So today topic is, after we create the functional requirement, the SA solution architect and the technical lead, they work together. They will prepare a technical design. Okay, so now let's understand the technical design. So today's topic we are going to discuss understanding the technical solution. Okay, so we are not going to look at developer view, so we are going to look at in the business view. Okay, so today is an exciting day. For the first time you are going to sit with a solution architect. Many business system analysts feel nervous before meeting like this. Okay, so they think I am not a developer, what if they asking about APIs, right? Technical question, you have this one. So every development these are involved. So if you are wondering, if you are nervous about this question, so these are very simple, nothing technical if you understand the concept. Okay, so what if I don't understand databases? Do you have these questions? If you have ever felt that way, you are not alone. Okay, so when everyone start, like even myself, when I start also, I had the same questions. Okay, so don't worry, you can learn this one. This is not a big deal. So here is the good news: you are not expected to build the system. Okay, you are expected to understand enough to connect the business with the technology. That's exactly what we are going to learn today. So 10 a.m. architecture walkthrough. So you enter the architecture room. So there is, by I'm saying, because this meeting is led by solution architect, or like or staff engineer, or senior senior developer, but just put it this way, some technical folks. Okay, but you are also invited. So David Chen, solution architect, is waiting. A large monitor display the system architecture. That's my welcome. Today I'm going to explain how our credit report platform works. He turns with the whiteboard. So let me show you the simulator here. Okay, so this is what end product going to what we are built. So this is the flow diagram. This is not the actual system, just a simulator, I want to say. So here here the customer are taking mortgages. That's the first step, right? And core banking receive this one. Here we have customer information, because you see, in our dashboard we need this one, right? Customer demographics. So that's why we need customer information. We need the mortgage amount, mortgage ID. That's why these systems are involved, right? Next one, the collateral system, right? Then combine this all data, because these are coming from in the mortgage dashboard. Here you see, right, we have different numbers. So these two are coming from here, right? The mortgage balance, mortgage ID, customer information, demographics data coming from here, and we have amount, it's coming from core banking, and we have collateral system, which have our number of past due and other stuff. So these are coming from different systems. So the API gateway is the because these data collected in the front end and in different format and different way, but in order to process this data, we need to transform this data. So that's the data analysis part, data cleaning, right? So that's why our next meeting is with the data engineer. So we'll talk more about how to clean this data, how to do the data analysis and those stuff. So just think, this is the API gateway, put all the data together, transform the way dashboard is required, because here is the transformation happening, right? So because here is the rules are there, because we gather all the data and we run a rule to see how many days past due, and it's filtering only active loans, only past due, see greater than 1 day, right? So some sort of transformation happening. That's the API gateway. And integration layer, everything put together and stored in the risk database. Then this go to the risk engine and see to populate to execute dashboard, right? So these all happening behind the scene. So you see API request is completed, um, risk database, risk engine, calculated high. So here is the um, rule is applied here. In the risk engine we have less than greater than 90 high risk and between 30 and 60 medium. So we didn't talk about that rule. I don't want to get you confused, but think all the business rules are in this evaluations are happening in the risk engine. Okay, here data transformation is happening, then data save in the so the integration layer, data transformation, API request, API get this all data and give here. Okay, so this is what this is the final dashboard. This is what our solution architect going to explain. So is it technical, guys? Yes, behind the scene, if you understand the solution, that's more than enough. Okay, so for us it's not nothing technical, like it's think about we are getting this data from different file folders, different in manual world, this different department, this is Sarah, this is Ram, this is Rami, so there is a orchestration layer, get everything orchestrated here, right, and store it there and run some rules. So if you imagine this manual world, this is what happening, but this is the digitalized version, but systematically a developer has to do. That's the walkthrough today. Okay, let's go back to the here. Okay, our technical design meeting. So step 1, where does the data come from, right? So we talk about what are the systems data coming from. Okay, so think usually there is no this kind of diagram they will show, but there is a flow chart diagram. So I want to show you, this is simple, nothing technical. If you heard the word technical, don't worry. Okay, so just focus about the functionality, not the implementation. How to do, that's not our problem, right? So that's technical folks can take care, but what functionality, that we need to take care of it. Okay, I'm talking about business analyst. Okay, so here David asks you a question: does your credit risk reporting application create mortgage data? You think for a moment, right? We don't create mortgage application, reporting application does not create mortgage data, right? Here, correct. Our application does not create mortgage; it consumes mortgage data from our other banking systems. He draws the first diagram. Remember, so this is a prerequisite dependency, right? So we for our engine, one of the previous lesson I was talking, right, somewhere here, I forgot. Okay, one of the functional requirement I was talking about, this one, right? So we consume input mortgage data, we process, and this is what happening, right? So let's focus on our diagram. So customers, okay, mortgage, I hope this is clear to you. The mortgage origination system create the mortgage application. This is still we don't take this data. Okay, so core banking system store the active mortgage. Okay, customer information, customer detail, demographics data, collateral system, property information. So Davis says these are the called source system. Okay, so if you are working with data, if you heard the word data is nothing but it's a piece of information. So you should ask what is the source system, because that source system we have a dependency for our technical components. Very important question when you are gathering requirements. So please, what is the source? Okay, they own the data. Step 2, why cannot we report directly? So you ask, if all the information already exists, why don't risk analysts log into each system? David laughs. Imagine opening 4 different applications every morning. It's in production. Okay, now imagine doing that for 1 million mortgages. He continues, we need to one place, like we need one stop shop, right? Because Data is everything, and also faster, real time. We need this one. Otherwise, customer will leave your company, right? So we need to provide the customized solution immediately. So step number 3, the integration layer. David adds another box, source systems integration layer. He explains the integration layer collects information from every source system. It validates the data, it transforms into command format, uh, then it's sent to our reporting platform. So the integration layer collects information, right? So let's go to our the integration layer. Let me reset. The integration layer collect all the data, right? Transform. So do you understand what is transform, right? Because these data, some data is string like a text base, some data is numeric, number, digit, integer, float, right? Different data types and different length, right? So we need to map. Data mapping is happening to the target system. So what is the target system is our database, risk database, right? So we need to, like, the system has to transform this one. So transforming mean A to B, just convert some format, right? Like whatever the end system downstream is required, the transformation is happening here, right? And also it validating the data, right? You understand validating, right? Because we cannot take close loan, right? So it will sort out, right? Common format, then it's sent to our reporting platform, right? So so this is where data quality checks happen. Exactly, that's why business analysts work closely with the data engineer. So next lesson we'll learn about the data transformation, data analysis, which is data cleaning, and data transformation we'll learn. Okay, the next step is APIs. So I'm planning to give a separate lesson about APIs. Stay focused. Okay, so David draws another component, mortgage system. So API call risk reporting platform. So he says an API is a simply a way for an application to request from another. So API is like a messenger. We talk about this APIs in different videos. It's just like a postman, or it's like a waiter or librarian. You can take whatever analogies you understand. It's like a carry the data from one system to another, communicator. It's like a messenger. Okay, so let's understand this application. An API is simply a way for an application request information from another. Think of it like ordering food. You don't walk into the restaurant kitchen, right? So you place an order, the kitchen prepares it, and the server brings it back. The API is the server. As a business system analyst, you don't build the APIs, but you should understand what information is requested, what information is returned, what happens if the API fails. Those are great question to ask in the meeting. Okay, so if they are talking about APIs, you have to ask what is the request, what is the response. Next step is microservices. Okay, so let's understand what's a microservice. The lead developer joins the meeting. He says we wouldn't build one giant application. We build small services. He sketches this: customer service, mortgage service, risk calculation service, reporting service, notification service. Each service has own responsibility. If the risk calculation service changes, the customer service doesn't need to change, right? If you build all the functionality in one application, think about one box. One box means, let's say we are building a washing machine. Let's say we are building a washing machine. Okay, so the buttons, we can build it on the washing machine, everything together. Otherwise, what we can do, we can build the buttons functionality separately, and we can assemble to the big giant washing machine, right? That's how the modern electronics and stuff built, right? So the phone itself, no one is one, for example, the phone manufacturer, right? So they don't, one person does not build the entire mobile, right? So there is a separate team. They're only in charge for building the camera, checking the quality of the camera. One people, they see the process, another people see other components, right? Like it's like building, because if you distribute the work to different sections, different department or different individuals, it's more efficient and the productivity is high, and also they will do the better job because they are again and again and doing the same thing. So that's the same component, same approach, strategy applicable for when software development, also when applications are built. So single application, one person monolith. So this is the microservice is, you are built like the platforms, the services are separately, right? So if any changes, we for example, if customer services change, we don't need to change these services, right? So we can just like fix this service only. Okay, so we'll understand more about microservice in upcoming lessons. Okay, so that's one of the advantage of a microservice architecture. Microservice is nothing but it's the architecture. Okay, it's a system responsible for one particular task. Okay, so that's the microservice. Name itself is saying, right? Micro is mini, right? Service, functionality. As a business system analyst, you may write requirements for one service without impacting the others, right? So now next step is databases. Let me recap where we are coming. Okay, so step 1, what we talk about the data. That's a source system. So from here you need to understand what is the source system. Okay, that's the first lesson. First question, why can't we report directly? Okay, so that because we cannot build directly, you need to log into different system, and also the data is huge, right? So we need a data warehouse. So that's the question answer in step. Data warehouse means centralized place. You got it, right? So source system, we are going to put it in one centralized data warehouse. You heard one single database is the data warehouse. Warehouse, you understand, right? We put, it's like your basement. We, all the garbage, all the things you want to store, you put it in one centralized system, wherever your cabinet or something. So this is where orchestration, we put the data together coming from different system. That's the second question. Third one, integrating. We are integrating the transform, so the data cleaning, like here integrating mean we are, it's coming from different system, right? Like let's say we are representing, there are 4 people representing different countries. Okay, like country A, country B, country C, country D, right? So we have a conference. Okay, here this conference, we cannot, the person, the 4 countries hosting, they cannot speak in 4 languages. Yeah, there will be translators, right? If the person can speak 4 languages, so this is just a redundant, but everyone should understand when the speaker is speaking, right? So what we can do, we can only do one common language, right? Like a kind of English or something. So that's the transformation. So the data is coming from different system in different format. The integration is the transformation happening, the common format here. Okay, next one, API. Like API, we explain how data transform one system to one system, right? So that's a request and response. Microservice, now we put together everything, right? Data coming from the source, and it's transferred through the APIs, then it's go to the integration layer, it's transform, and it's stored in the data warehouse, like one central system. Okay, so now we are coming to the databases. Databases is the place where we store the data. So Rachel, data engineer, opens the database diagram. She explained after data is validated and transformed, we stored in the risk database. you ask, why not read directly from the core banking databases? Because whatever you are seeing, these also databases, right? So that's the question we have. That's a valid question, right? After data is so after data is transformed and everything ready, why we need to store in the REST database? Can't we read directly? So why not read directly from the core banking database? Rachel answering, because operational systems are optimized for processing and transformations, right? Reporting systems are optimized for analysis, right? That's an important decision here, distinction, right? So every database has own purpose, right? Databases made it for storing data, right? But when we this database frequently, it's writing data and reading data. Writing means storing data or modification happening. That's the storing part, right? Writing, I would say writing, and reading, viewing, and data is fetched, right? So these are this should happen within milliseconds, right? So if you distract the operations, right, like this is for different operation. Customer, we are requesting customer data, decision is made, and we send him back to the the mortgage decision. That's for different operation. So now we are analyzing data for different purpose, right? So that's why it's we can share a database, but it's a different functionality, different operation, right? um, so we don't want to delay one operation, right? That's more important. So that's why banks often separate transactional system for reporting system to improve performance and reliability. That's exactly right. So we don't want to delay, like think multiple workers are working asynchronously for like think you take your car to a garage, okay, for repair. If one mechanic going to do right your repair, it's going to take time. But let's imagine we have multiple experts, mechanics going to do. You think about like a Formula 1 race, like a car race, right? Within few seconds they will repair it and put on the track. That's what we have to do, because the business is like a race, right? Like if you cannot meet the SLA, like within 2 seconds or 3 seconds, customer will leave your company, right? There are other competitors, they can make faster services, right? Because data is very important, the reliability, like the response faster. The like, do you like if you withdraw money and the ATM machine is keep on spinning and saying that please hold on, we are processing your request, right? Let's say you can wait 10-20 seconds, but if it is take more than 1 minute, right, like something, will you consider to do banking with the same bank, right? And if the competitor is providing like immediately. So that's why we need to maintain different databases, right? Like databases are like a toolkit, right? Like the operator A come here and get his toolkit and do the job and fix that place, right? Let's say if you combine these two databases together, the worker have the same toolkit, right? Like this person is taking doing the fetching query, and this person also doing the fetching. It's like a taking, let's say here we need a spanner number 5, here we need the spanner number 5. So whoever took first, this guy has to wait, so there's a delay happening here, right? But if you have separate system, this guy got also number 5 spanner, this guy also have 5, asynchronously without interfering to without waiting, and this task happen real time. So that's why we keep the performance and reliability, like availability, like companies, not only the banks, companies keep separate databases. Okay. So number 7, risk calculation engine. David opens another component risk database, risk calculation engine, risk data dashboard. So he explained this engine applies business rules. Example, if days past due and greater than 90, then risk category high. Usmail, I recognize that rule. We documented it during the requirement workshop, right? So David notes exactly business rule become system logic. This is where the business analysis meets technology. Step number 8, final our expected output. Reporting dashboard. This is what where the business sees the dashboard displays, right? Total mortgage exposure, high risk mortgages, delinquency trends, geographic distribution, executive KPIs, Emily, the credit risk manager. The dashboards help us make business decision. We don't care how many APIs were called, right? Exactly, this is your point. We care the numbers are accurate. That's another important lesson. Technology supports the business. It is in the business, right? So your questions before the meeting ends, you ask where does each data file uh, come from, how often, that's the source system, how often data is refreshed, right? How frequently, what happens if an API is unavailable, who owns each source system, which microservice calculate risk, which team support production issues. Those are exactly the question I expect from the lead business system analyst. So what you learned today, you don't need to write code, but you should understand source system, integration layer, APIs, microservices, databases, business rules, reporting dashboards. When you understand these concepts, technical conversation become much easier. Okay, so your assignment, draw your own architecture diagram, which you don't need to do in your world, but just to understand, because I explained, right? So systems, integration layer, APIs, risk database, risk calculation service, dashboard. Then answer which system owns the mortgage data, why does the reporting application have its own database, why, what is the purpose of an API, what does the risk calculation service do, why do banks use multiple microservices instead of one large application. Keep your answer simple. The goal is understanding, not memorizing. Okay, so what's coming up next? Tomorrow you will work with directly with the data engineer Emily. So I forgot the data engineer name, but you will work with the data engineer. You will learn how data moves through the system, how to perform data mapping, and how business system analysts use SQL to validate banking data. This is where you will begin thinking like a technical business system analyst. Okay, so one more time, let's reset this application and you can see what steps are happening where. Okay, so mortgage created from the origination system, and mortgage stored in core banking here. Okay, next one, customer profile is loaded, demographics. Okay, next one, collateral value loaded, and API request completed, integration layer, data transformation is completed, and risk database data saved into the risk database. Risk engine now runs and evaluate the data and applying the rules. Okay, so the expected outcome we got is high, dashboard updated here. So this is one entire giant thing happening. It's all connected, but we have different services doing the different jobs efficiently. Okay, so you can see one sample. Top up this risk database because we have a lot of data here, and we can create multiple rules, and we can play around and create very fancy, very more effective KPI reports. Top up this database. Okay, so that's end up lesson number 7. So I'll see you guys with lesson 8 with the data analysis. Thank you.